Hi, my name's Econ, and today I'm going to go over the 2025 AP Calculus BC Calculator FRQ section. First question. An invasive species of plant appears in the fruit grove at time t equals 0 and begins to spread. The function c defined by c at t equals 7.6 arctangent 0.2t models the number of acres in the fruit grove affected by the species t weeks after the species appears. It can be shown that c prime of t equals 38 over 25 plus t squared. A. Find the average number of acres affected by the invasive species from time t equals 0 to t equals 4 weeks. Show the setup for your calculations. So for A, just find the average number, and we have time 0 to 4. So first we do 1 over 4 minus 0. And then the number of acres affected by the invasive species is CT. So we do an integral of 0 to 4 CT. Now if we put that in decimals, let's do CT is equal to 7.6 arc tangent 0.2 x. We can replace t for x. I mean, we wrote t over there, so I guess we have to use t. And then what we were trying to find was the average rate of change from 0 to 4. So, okay, 1 divided by 4 minus 0. And then the integral from 0 to 4 of CT. That comes out to 2.778. So our answer would be 2.778. B. Find the time t when the instantaneous rate of change of c equals the average rate of change of c over the time interval 0 to 4. So let's first find the average rate of change of c over 0 to 4. That would be c of 4. Well, first, it's an average rate of change, so the denominator would also be 4 minus 0. And now we're finding the average rate of change instead of the average number of acres. So we would write c of 4 minus c of 0. And then it says that equals to the instantaneous rate of change. And we have c prime right here, which is 38 over 25 plus t squared. Now we have to find t here. So let's find c of 4 let's find the average rate of change of c minus c of 0. And that equals to 38 over 25 minus plus t squared. Do I have to do x? Okay, so we can can find the intersection here. Which is 2.14. Well, that's fine. So how do you find it? How do you find the intersection? Well, if you have a different calculator, you would get the answer 2.154. Assume that the invasive species continues to spread according to the given model for all times t is greater than 0. Write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species. So the end behavior of the rate of change is c prime of t, which is 38 over 25 plus t squared. We have to find the end behavior when t is greater than 0, so as t reaches infinity. So here, as t reaches infinity, the denominator also reaches infinity, but the numerator stays the same as 38. So the denominator reaches infinity. So the answer, the limit would be 0. D. At times t equals 4 weeks after the invasive species appears in the fruit grove, measures are taken to counter the spread of the species. The function a, defined by a of t equals c of t minus integral blah blah blah, models the number of acres affected by the species over the time from 4 to 36. At what time does this attain its maximum value? So to find the maximum value, we have to first find the critical points. So we have to find a prime equals c prime of t minus 0.1 times ln t. And to find the critical point, this has to equal 0. So we should put that in the calculator again. 38 over 25 plus x squared minus 0.1 ln x equals 0. So if you put that in a calculator at Desmos, it doesn't give me the exact number. I don't know how to operate Desmos that well, so that might be on me. But the exact answer, well, here we can see it's between 11.4 and 11.6. 11.5. And the exact answer is actually 11.442. For justification of this answer, we can say that a prime is when a prime of t equals 0, that's the critical point, which is the maximum value. And a prime of t is equals to c prime of t minus 0.1 times ln t. So we find when this is equal to 0, and we get 11.442.